I think it starts with the material that was on my quiz, like the first quiz I took.
Okay.
Yeah,
No
and
worries.
then
Sorry.
goes up to what I sent you now.
Okay. So what I'm gonna do is sometime as soon as I wake up tomorrow, like I'll try to do it, sooner than later. I'm going to create as usual. I'm gonna create like a cumulative test for you that you should take, and we'll go over that like sometime tomorrow. Okay?
Okay.
Okay, cool. So, as I was looking through your material, like I was like, as always, like happy about like your handwriting. You have like so other than like a voice career, if you're lost for what to do, you have like a writing career also. You're welcome. All right. So, sorry. So, like, I guess we could just go through it. Like, the notes are like very well filled out. So there are places where we really needn't say much, but I will try to succinctly summarize everything that's written on here. So, like, just for the first page. So, like, this is about obviously this lesson is about quadratics. This particular set of notes, and like we know that quadratics can be written in this form, uh, or this form. Sorry, a times x minus h squared plus k. No. Okay. So what do you know the name for this latter form?
It's like point slope or something. I don't even know. It's one of the.
It's okay.
I don't know.
It's okay. Sorry. It's called the vertex form.
No.
It's okay. Um, Sorry. Now, so looking at the vertex form, the reason why the vertex form is so nice is because it's got like a lot of information already written in it, which is that like, you can tell where the maximum is, you can tell what the maximum value is, you can tell the axis of symmetry, and yada yada. So, when you're given a quadratic in vertex form, how do you quickly figure out what the vertex is? It's always a specific coordinate in this form. What is the vertex?
Isn't it like H comma K?
Yeah, there you go. Beautiful. So h comma k. Now, so what is the vertex though? And not like what are the coordinates, but what is the meaning of the vertex?
It's like the highest or lowest point on the graph.
Yeah, bingo. So how do you decide if it's the highest or the lowest point?
Um, does it have to do with whether like it's negative or positive?
Yes, exactly. Whether what specifically is negative or positive.
No. Would it be A?
Exactly. So whether A is positive or negative. So let's say A is positive, meaning positive is another word for A is greater than 0. So if A is positive, then what more can you say about the vertex and yada yada? Go ahead.
Then if A is positive, then the vertex is the highest point.
Mm-hmm. Which way does sorry?
Point.
Yeah, exactly. Because which way does the parabola open if A is positive?
Oh, like a U, I guess.
Exactly. So the vertex will be the coordinate of like both the x coordinate and the y coordinate of this point right here. Um, and so there are two things. One is like in the vertex, this is h comma k right here. Now in the vertex, h is the x coordinate of the vertex. It's also the axis of symmetry. So the axis of symmetry, if you're given the vertex form, is always x equals h. And this stuff is gonna help on the SAT prep to come soon. Okay, so the axis of symmetry is x equals h. And the what about the k? What does the k tell you about the parabola?
Um, wouldn't if it's H comma K, wouldn't that be like the Y value?
Exactly. So it's where the minimum, in this case, where the minimum value occurs. So k is, sorry, it's not where the minimum value occurs. If it opens up, h is where the minimum value will occur. But k is the minimum value, the actual minimum value. And so similarly, if a is less than 0, meaning the parabola opens down, still h is going to be the x coordinate of the vertex, but also the axis of symmetry. But the k this time is going to tell you the maximum value. So the difference is that like the y coordinate is the value. versus the x-coordinate h, which is where the maximum or minimum value is attained. Okay, I think we just like, in saying all that we just said, summarized everything that is on this first page. I mean, I can give you like, my own examples of like what you're being asked for here, but I feel you like have gotten it. Sorry, I suppose it's worthwhile to talk about the coordinate and the y coordinate, which are things I feel you sufficiently understand. But let's do it anyway. So here's my made up quadratic. So y equals -2 times x plus 3 minus 4. So a question. One is, what is the coordinate of the vertex?
So the vertex would be 3 comma -4.
I was trying to trick you. One more try.
Would it just be 3 comma 4?
No, you got the y coordinate right. So -4 is definitely. Go ahead.
Oh, so wait, would it be 6?
Sorry, I'm confusing you. So let me show you one thing. I boxed in what I wrote in red. I just boxed the x, the squared quantity. Look at that and compare it to this.
There's no square on it.
Oh yeah, so that's my bad. But h is not
negative.
Yes.
So would it be -3?
Exactly. So if it's x plus a number, you got to take the negative of that, because in the vertex form it's supposed to be x minus h. So the h had to have been a -3, so that way it's x minus a -3, which is why it's x plus 3. Make sense?
Yeah.
Okay, that's just small detail-oriented stuff. You get the big picture. Okay, now, so does my specific example, does it have a maximum value or a minimum value?
So that would be a minimum value.
Sorry, on my example right here.
Well, yeah, wouldn't it still be like the lowest point almost?
Does it open up or down? This guy here.
Well, it opens down because a is negative.
Exactly. So if it opens down, then does it have a maximum or a minimum?
Oh, right. So that would be a maximum.
Yeah, exactly. It has a max. What is the maximum value?
-3 comma -4.
The maximum value occurs at x equals -3, but the actual maximum value is the k. So it's y equals -4 is the maximum value. Exactly. Okay, cool. Now, what about the axis of symmetry?
Yeah, this part I'm a little bit more confused.
It's okay. It's always x equals whatever h is.
Okay.
So what is it in this case?
So x equals -2.
Whatever h is.
Oh, h, not a.
It's okay.
So -3.
Exactly. What does x equals a number? What kind of a graph is that? If you graphed x equals a number, what graph is it going to look like?
A vertical line.
Exactly. So if you go to x equals -3 here and draw it, it's going to be the axis of symmetry, because it's the vertical line that will divide the quadratic exactly in half, mirroring it, the left side of the quadratic and the right side of the quadratic. Okay, staying on my example. Sorry. What is x-intercept? How would we find it?
I was gonna say -3, but then I realized.
It's okay. Let me ask an easier question. What is the y-intercept, and how would you find it?
Well, wouldn't that just be the k value?
The y-intercept is always x equal, by plugging in, what you find by plugging in x equals 0. Right?
Yeah.
Okay. Mm-hmm.
So if x was 0, it would just be -4.
Let's make x 0 my example. Then we're going to get y equals, it's okay, don't worry. -2 times 0 plus 3 squared minus 4. Help me simplify.
Okay, well then it would just be 2 times, -2 times 0.
It's okay.
Oh, right, because it's 3, so you have to square the 3. So then 9, so -18 minus 4.
Exactly. And so that's -22. So the x-intercept in this case would be, sorry, the y-intercept. That's where we're at, my bad. The y-intercept would be y equals -22. Really, like it's a coordinate, so we'd say 0, comma, -22. So that would be what the y-intercept is. So y-intercept just for lines, and for parabolas, and in the future when you learn even more advanced functions, y-intercept always make x 0. X-intercept always make, finish the sentence. What about for x-intercept? Always make
Y 0?
exactly. So if we set y equal to 0, and my specific example in green, what are we going to have to write?
So just set that whole thing equal to 0.
Exactly. So 0 equals -2 times x plus 3 squared minus 4. We add 4 to both sides, and so that's going to give us 4 equals, and then it's going to say -2 times x plus 3 squared. We're going to have to divide by -2. So I made up an example that's kind of whack, but like that's going to say 4 over -2 is -2, so it's going to reduce to -2 equals x plus 3 squared, but you have the technology, meaning you have already seen this idea, so we can finish it. And so, like, the next step, obviously, is to take the square root of both sides, and when we do, we're going to have to write square root of -2, so I'll, talk through this one a bit more. So, square root of -2, but when we take the square root, we mustn't forget we have to write plus or minus, but square root of a negative number is what kind of a number? Do you recall?
Imaginary.
Yeah, exactly. Bingo. Excellent. So then what we have is plus or minus I times the square root of 2 equals x plus 3. And so then we subtract 3 from both sides, so we're going to get x is equal to -3 plus or minus I root 2. So since we got here by making y 0, it means that there are two x-intercepts. One of them is -3 plus I root 2, comma 0, because y is 0. And the other is -3 minus I root 2, comma 0. So as we always have known, imaginary roots, which is x-intercepts, every time we say roots, which is solutions, we mean x-intercepts. So those come in tandem, one with a plus, imaginary ones, and one with a minus. And again, we got there by setting y equal to 0, so these are the two. So there's often two x-intercepts, but there's only one y-intercept every single time for parabolas. And since this lesson is not focused about imaginary numbers, perhaps my example is having us a discussion like that's not very focused, because we don't need to talk about imaginary numbers, but maybe it's like an extra guard on what you might be tested on. What we said when we were talking about the imaginary numbers unit is if you get imaginary numbers as your solutions when you set y equal to 0, it means that the parabola does not cross the x-axis. And so I gave you an example of a parabola that does not cross the x-axis, but still faces down. Okay, cool. So we've actually said more than we need to. The examples that are presented on your note are like much more straightforward than the one I just looked at, and so then you don't need to worry about anything else on your notes. Definitely on the first page anyway. Now, beyond the first page, this is what we've got. On the sorry, no, on the next page, we said that the other form of the parabola, if we're not talking about the vertex form, is this form. This is called the standard form. So, and you don't really need to know the name for it, but standard form. It's easier to factor and solve blah 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 like from the standard form. But the standard form is not as convenient when you're looking to graph because it doesn't right away tell you the axis of symmetry or the vertex or the maximum value, blah, blah, blah. So you have to do a little bit more work. So in the standard form, how do you find the x-coordinate of the vertex, meaning h?
Well, wouldn't you...
It's okay.
Yeah, I'm not sure.
It's okay. X-coordinate of the vertex. In the standard form, when you're given this form, the x-coordinate of the vertex is always the following. I'll let you cheat. Go ahead.
Could you repeat that? You completely cut out.
Yeah, sure. No worries. So I'll let you look at your notes real quick and tell me. So what is the x-coordinate of the vertex in the standard form?
Negative b over 2a.
There you go. So you got to go x equals minus b over 2a. So you just got to do that. And so let's write down a specific parabola. So y equals 2x squared plus 8x plus 3, let's say. Then how do I find the x-coordinate of the vertex?
Well, wouldn't you just plug it in 8 for b?
Yep, so negative 8,
and then 2 for a.
Over 2 times 2. Simplify, tell me.
Well, it's just negative 8 over 4.
Yep.
Which is negative.
Yep, exactly. So you get x equals negative 2. So this is the x-coordinate of the vertex, and so this is h in the vertex form. Remember, in the vertex form, you get it for free. You just have to look at the parabola. The only thing you have to worry about is is it x plus or x minus? And if it's plus, again, it's the opposite. It's going to be, h is going to be negative. If it's minus, h is going to be positive, blah, blah, blah. But in the vertex form, you get it for free. Here you have to do this bit of work to figure out what it is. So what is the axis of symmetry in this form?
In this form? Yeah, I'm not really sure.
It's okay. It's okay. It's okay. So if I draw a generic parabola and I say this, what would 2 have represented right here? What would that have represented? The negative 2. Sorry, go ahead.
The x-intercept.
It's okay. Go ahead. Take your time. No worries.
Well, if it represents h, then would it just be down the middle?
Yeah, it would be the x-coordinate of the vertex. So then that's automatically the axis of symmetry. Because in the in the vertex form, h is not only the x-coordinate of the vertex, but it's also the axis of symmetry. So here, minus b over 2a, it's both the x-coordinate of the vertex, so it's h, and therefore automatically the axis of symmetry. So right here. The axis of symmetry in this case would be what again?
Negative 2.
Yeah, the line x equals negative 2 would be the axis of symmetry. There you go. Okay, cool. And how would you find since in this case a is positive, it means that our parabola opens up. So how do you find the minimum value? We know that we're going to have a minimum value since the parabola is opening up. So what is that minimum value?
Isn't this where you have to solve for x and y?
So say more. What do you mean?
Well, I mean, what you need to find, I don't know what you mean by when you ask me that you want me to elaborate on it.
No,
Sorry.
It's okay. It's okay. So, in the vertex form, the k is automatically the maximum or the minimum value. And we say or because, well, it depends if it's facing up or facing down, just repeating myself. Now, in this form, we had to do this minus b over 2a to find the x-coordinate of the vertex. So how do we find the minimum value, which is the y-coordinate of the vertex.
Right.
We have sorry, go ahead.
No, you can.
So we have to plug in this x-coordinate of the vertex. We have to plug it in the y equation everywhere we see an x. So it's going to be the minimum value in this case, which is this spot right here, the y-coordinate. We have to do 2 times negative 2 squared plus 8 times negative 2 plus 3 to find it. So talk to me. What is that?
So then that would be 8 minus 16 plus 3.
Mm-hmm.
And then that would be negative 5.
Yep. I mean, I have the same problem, but like, I think like the biggest issue on our like test, and my advice for you, like on this test and on any other test, and especially on the SAT, because the stakes are a little bit higher on the SAT. But again, I'm very proud of like where you started with your PSAT score. But yeah, like the biggest issue, which is the same issue I have like when I do math, is careless mistakes. So do not rush. I feel like you know stuff really well and you understand stuff really well, but like you're maybe eager to finish. I don't know, but like no more careless mistakes. However you that's hard to teach, but however you can avoid that, like let's work on that. But I think you can get an A in your class like if you could manage like careless mistakes or rushing on problems. Okay, cool. I mean, I didn't see it here. It's just my paranoia talking. Okay, sorry. Now over here, like, and what is written as 2, like, I feel like we, okay, I can't write. Okay, whatever. What's written in Roman numeral 2, like we've already said. And I feel like you know it, so we don't need to talk about that. And example 3 also, like, we don't need to say anything much. Like, I have a little something to say about C, but like the A and B, like, you got it. What I would emphasize is in B, notice, again, just like we did, they found the x-coordinate of the vertex, which is h, by doing minus b over 2a, but then to find, and I really like that you underlined it, to find the maximum value, and this one has a maximum value because the parabola faces down because a is negative, but to find the maximum value, you have to plug in that minus b over 2a value, which is negative 3, into everywhere we saw an x, so as to get that 21. So the maximum value, because the parabola faces down, is y equals 21. It's the y value. So the h is negative 3, the k is 21. It's just that, again, since this is the standard form, it doesn't automatically give you the h and k. Okay. And so here, actually, I'll ask you a question. In example 3, you can use the work that you have done here. What would be the axis of symmetry?
Isn't it just like the line down the middle?
Yeah, and what would that be? What would the equation of that line be in this example 3?
X equals negative 2.
X equals?
Sorry, my iPad like just completely
okay.
broke down. I'm trying to pull up the
It's okay,
picture.
don't worry.
Okay. Example 3, you said, right?
Mm-hmm. You can use anything you've written there, but yeah, what is the equation of the axis of symmetry?
Would it be negative 3?
Yeah, x equals negative 3, exactly. It's always x equals h if you're given the vertex, otherwise it's x equals minus b over 2a if you're not given the vertex form and you're given the standard form. Fair?
Yeah.
Okay, the only thing we need to discuss on this page, other than these things, is, sorry, I'll tell you at the end of it, like, why I'm laughing. But anyway, C is, so in C, like, the domain. So what can you say about the domain when working with quadratics?
I guess, I don't know, is it usually like infinity?
Not usually, always negative infinity to infinity. So for parabolas, you don't have to worry. The domain is all real numbers. So from negative infinity all the way to positive infinity, you can answer it this way, or you can say all real numbers. Fair?
Yeah.
Okay, cool. Now, for range, range is like a tricky subject. It's not that tricky. I don't want to make it sound that way. But it's a tricky subject usually, especially for more complicated functions that I'm sure we will encounter as you study more algebra 2. But range is almost always better done if you have a graph, if you can visualize the function. Now, you don't need to always visualize it. I'll show you a way to answer the range question without visualizing it. But it's helpful if you have the graph. So, if I gave you this is like the y value of the vertex, let's say is 3, then what would the range of this function be now that you have the graph? What does first of all, what does range mean?
Well, it's like all the y values.
Yeah, all possible outputs, exactly. Oh, domain is all possible inputs. And as we said, for parabolas, you can put in any real number. For range, like you just said, it's all the possible y values of your graph. So what are those here?
So, do you still mean for example 3?
For my graph right here.
Okay. So would it be like negative infinity, comma 3?
Beautiful. Negative. Yeah, my bad. You can never use a square bracket on infinity or negative infinity. So soft bracket on negative 3, but it includes 3, the maximum value, since it's facing down. So you have to use the square bracket. So here it is for range. That's how you'd answer it. Now, okay, but what if you don't have the graph? So what if you just have, let's say it's in vertex form and it's y equals negative 2 times x plus 4 squared and then minus 8. So how would you answer the range of this question? For my specific example here that I just wrote down, I'll circle it in blue, right there.
So would it be negative infinity, comma negative 8?
Yeah, exactly. Excellent. Negative infinity, comma negative 8. It's facing down. The k in the vertex form automatically gives the maximum or minimum value. So then that's it. Good job. Excellent. One more. So if I have y equals, let's say it's 2 times x plus 3 squared, and then it's plus 1. So what about the range of this? We know the domain is negative infinity to infinity. But what about the range of this new one?
Negative infinity, comma 1.
Which way is it facing this time?
Negative 1.
Which way is it facing? Is it opening up or down?
Up.
Yeah, so when it's facing up, it has a minimum value.
So would it be positive infinity?
Yeah, positive 1 to positive infinity. So now the k value is the starting of the range, and positive infinity is the end because it's facing up. But when it's facing down, negative infinity is the start, and the end is the maximum value. Does that make sense?
Yeah.
Okay, awesome, great. All right. We make a good team, I think. Okay, all right, so I think we've said everything we need to say there. The application, these application questions are really silly usually, because what happens is this, right? What happened, have you ever seen, have you ever seen the TV show It's Always Sunny in Philadelphia?
No.
Okay, all right. Well, not every episode is funny, but there are some episodes really funny. One day when I'm bored, I'll text you with the specific episode you ought to check out. It's on Netflix, but there's this lady who talks in a funny accent. That's who I was trying to copy. As soon as this session is over, I'll send you one little link of her. I think you'll laugh. Anyway, what happened was so an example for it's always these application questions of maximum, minimum values and parabolas are very silly because it's this is what happens, right? You throw a baseball, let's say. Well, okay, when you throw the baseball, the trajectory, just like a way water falls, it's gonna become a parabola. And it really is a parabola, even the way a water falls from a fountain and the way a baseball goes, blah, blah, blah. When you're, first of all, when we solve, when we set y equal to 0, it tells us the x-intercept, so this spot and this spot. So in real life applications, the negative coordinate frequently doesn't make sense. For example, for a baseball throw-in, like the negative, when you set y equal to 0 and you get two x values, let's say this is x equals -1 and this is x equals like 7, the -1 doesn't have any real life meaning, because, well, what could it mean? Because you had to be like a man or a woman, but not like, the not the he or the thems, but you are. I'm just being ridiculous. I'm sorry. So, so you are a man or a woman, and then you throw a baseball. Well, you have a height. You're not throwing it from the ground. So that's what the y-intercept represents. Because you're not throwing it from the ground. You're throwing it from your hand. So that's above ground. So that's what this spot represents. And for that, since it's a y-intercept, we do what we always do, which is set x equal to 0 to find that spot. Now, otherwise, when you throw it, the other question you'll be asked is like, where does it land? How long, like from the time? And usually, instead of x, they'll say time, t. Is that the case here? No, they use x here in example 4, but usually it's t. So they'll say like, how long does it take for the ball to hit the ground? Well, they're asking you for this other x-intercept. So what you would do is, since we're talking x-intercepts, you would set y equal to 0. That's going to give you two values, one over here, one over here. You discard the -1, and then you report the +1 as the time that it hits the ground. But the other question they'll ask you frequently is, what was the tallest height that the baseball achieved? Well, they're asking you for the maximum, which is the y-coordinate of the vertex. And we just talked about how to do that. You just find the x-coordinate, minus b over 2a, and then you plug that into the function to find the y-coordinate, which will be like the peak of the baseball, the highest height it achieved. And this minus b over 2a will be where that maximum height is achieved. And since in real life applications, you're talking about like a trajectory of some object, it will always be a parabola that's facing down. If you look at if we come back to example 4, if you see clearly the parabola starts with a negative 0.01, blah, blah, blah. That's because, well, again, since it's representing a real life thing, it's going to be a parabola that's facing down. Nothing falls like a parabola that's facing up. Okay, now, so I don't know, what value you're going to get from us discussing this example further than this, more than this. I intentionally discussed it away from, your notes so that I can say something that's not already in your notes. But I feel like I've just got done saying. Let me know if I need to say more about example 4.
No, I think I'm good.
Okay, got it. So let's go to example 5. I feel that this might not have been decide what is to be minimized. Find the vertex. Well, actually, let's go. Yeah, so read example 5 and do you want to read through your notes together, or do you want me to do it away from your notes, example 5?
I mean, whatever you think is better, honestly. I don't have a preference.
Okay, dear. Sorry. Well, read example 5. Read it for both of us.
Among all pairs of numbers whose difference is 8, find a pair whose product is as small as possible.
Okay, no.
It's as small as possible.
Yeah, sorry, no worries. Okay, so when it's saying as small as possible, is it talking minimum or maximum of a parabola?
Minimum.
Yes, exactly. As small as possible. As small as possible. That's min. Got it. Now, get this, kiddo. So this much you don't have to worry, which is that if in the question it says find the minimum value, so long as you set up your equation correctly, the quadratic that you will end up is going to start with a negative. Well, no, sorry. If it's a minimum value, the parabola is going to start with a positive, because, well, that's the only way you can have a minimum value on a parabola, as if it's facing up, meaning the leading coefficient, or the a, and the parabola will have to be positive. In other words, if in the question they say minimum value, then your setup should lead to a parabola that faces up. Otherwise, double check your work. And if it says a maximum value, then when you set up your equation, you need to have a parabola that's facing down. That is, the a value is negative. If that does not happen and they mention a maximum value in the question, you did something wrong in your setup, so double check your work. Since here they said minimum value, if we set up this correctly, then we need to end up with a parabola that's facing up. Now, what did they tell us? They told us among all pairs of numbers. What could those pairs of numbers be? We don't know. When we don't know items in math, we call them x and y. So fine, these are the pairs of numbers, x and y. What happened between them? Their difference is 8, meaning x minus y. We don't know which is bigger, but doesn't matter. So you can choose whichever one. Like, you can lead with whichever one. It won't matter. So x minus y is equal to 8. Why did I write that? Because they said their difference is 8. And they said, find a pair whose product is as small as possible. Ah, I see. So the equation we need to write is p equals x times y. So, like, because it's their product meaning multiply. So we need to make x times y as small as possible. Got it. Now, this is not a quadratic though. It says x times y. Worse yet, it has two variables. It's not, we can't say y equals, well, because y is involved as one of the variables. So, like, that's why I chose p. Where y, we would have normally had y equals, we have p equals. But doesn't matter. P is a letter just like y. So, anyway, we have x times y. But x times y is not a parabola. But we turn it into a parabola by using the other unused equation. The other unused equation is x minus y equals 8. In it, we solve for y. So how do I get y by itself from that first equation all the way on top?
Just move x to the other side.
Yeah, exactly. We could do that, and or move the y to the right, move the 8 to the left. It doesn't matter. Either way, we're gonna end up with x minus 8 is equal to y. Got it. So now what you're gonna do is you're gonna take this x minus 8 and substitute for y right there in the product part. We have the product p is x times y, but now it is x times, because we need an equation only in one variable. So we have x times y is x minus 8. Got it. Now, if you want to get this in standard form, because now here, it's not the standard form or the vertex form. The vertex form doesn't have an x times another x, so we need to get to the standard form. So just FOIL. So that means x squared minus 8x. We see, oh, okay, we know the parabola faces up. And so we need to figure out how to make, what is it asking? Like their product. We need to make p as small as possible. Meaning we need to figure out the value of p where it is minimum. Well, that's just minus b over 2a, and then plug in minus b over 2a into the p equation. So first, let's figure out where the minimum value occurs. So to find where the minimum value will occur, it will have to be minus b over 2a. If it was where does the maximum value occur, it's still minus b over 2a. But to find the maximum or minimum, after you do minus b over 2a, you need to plug it into the equation. Okay, so let's start with finding minus b over 2a. So where is that?
What do you mean where? Or do you want me to solve for it?
Yeah, exactly. Solve for it. Talk to me.
Okay.
I'm out of breath. Go ahead.
So would it be negative 1?
What's in this p equation? What would minus b over? Oh, maybe you did it very quickly. No, what's minus b over 2a?
Well, so the a value would be 1. Sorry.
Yes.
And then the b value would be 8.
Yeah. So 8 or
negative 8. Sorry.
Yeah, it's okay. It's okay. So we would have minus 8 over 2 times 1. So that's gonna say positive 8 over 2, which is 4, right?
Mm-hmm.
Okay, cool. So x equals 4 is where the maximum or minimum will occur. And then, well, since we need to find the minimum value, so they're asking you for, what are they asking for? Find a pair whose product is as small as possible. So we need to find the value. So to find the value, what are we gonna do? The minimum value.
So I guess then would you plug 4 in?
Yeah. Yeah, exactly. So p equals 4 squared minus 8 times 4. That's 16 minus 32, which is negative 16. So the smallest, the minimum value of the product of the two numbers would have to be negative 16. Now they did say find the pair of numbers. So first define one variable. Yeah, okay, so your teacher has had you set it up very nicely. Decide what is to be minimized or maximized. Well, the product of them. And the equation of the product is x times y. Use any additional information so that you could use your equations. Step 3 has one variable. That's where we like took the first equation, the unused equation x minus y, that's the additional information, equals 8. We solved for y and we plugged in place of y, x minus 8, so as to turn the whole thing into, a function of one variable, and all in terms of x. So that's what she's talking about in this step 4 where it's blank. Okay, otherwise the two numbers are, well, okay, so we found that the minimum value is negative 16. Now, at the top, at the start of the question, it said find the two numbers. So to find the two numbers, what you do is you take your equation once you got it all in terms of x, which is p equals x times x minus 8 in factored form, and set it equal to 0 to find the two numbers. So when we set it equal to 0, we get 0 equals x times x minus 8. Well, from there we get x equals 0 or x minus 8 equals 0. So from the x minus 8 equals 0, we get x equals 8. Now, x equals 0 will trivialize the whole thing, because 0 will definitely make you small, but it like annihilates everything. It turns everything into 0. So you toss that out. Kind of like the same way in the application problem, why a negative value doesn't make sense when you toss a baseball. So if you get like find two number, a similar question to this one, where you like have to find a pair of numbers, and one of them is 0, you could just ignore that. But the other value you got is x equals 8. Fine. If x equals 8, then we have a way to figure out what y is. Y is equal to x minus 8. So that will say y is 8 minus 8 or 0. But did we set up our equation incorrectly? Because then that would say the second number is also 0. Sorry, one of them is 0. So then the minimum will be like 0 times 8, which would give us a 0. But that doesn't make sense. So what happened here? First number is 4. The second number is negative 4. And their difference is 8. Yeah. But how do you get there? Like, wait, what? Yeah. How do you even get x equals... Oh, wait. No. Okay, I see. From this, x equals 4. Got it. Okay, got it. So yeah, we're not supposed... Sorry, ignore everything I just said about, like, setting p equal to 0. I apologize. So, yeah. Okay. So, you take... on a similar question, the way you'd find one of the numbers is by minus b over 2a. So, we had found that that was 4. And we have an equation that says, over here, y is equal to... From their difference, from that equation, we have y is equal to x minus 8. So that means y is equal to 4 minus 8, which is y is equal to negative 4. Julia, I swear, if I finished my master's degree, like I know enough math today to teach college. So I know you have faith in me, but I'm sorry about yeah. Okay. So yeah, sorry, can you, to save face, can you tell me how we would find the two numbers? Can you summarize that part?
Yeah, okay, so I guess I remember writing in my notes something about x equaling the first number, so wouldn't that be 4?
Exactly. One of the two numbers is going to be the x coordinate of the vertex, which is minus b over 2a. And just to repeat myself again, it's the x coordinate of the vertex, which is minus b over 2a. For the parabola, is also the axis of symmetry. So h is also the axis of symmetry. The other number you will find by their difference or their sum that you were told, and you'd set up an equation for that. So you'd use that to find the other number. So we got the negative 4 from knowing that their difference is 8. So knowing that one of them is 4, we do 4 minus what equals 8, and it becomes clear The other one has to be -4. Okay, cool. All right, this is it for me and for you. And what is it today? And I'm gonna, as I said, look through what you'd sent me in the past and create a full length test for you, which you'll take. What's your schedule like tomorrow, so that I know, when you could accommodate that?
Well, I think the earliest I'd be able to meet is like 7.
Okay, that's okay. Do you still do fencing?
Yeah.
Okay. And so where would you fit in sitting down and taking a test?
Um. Well, I guess I'm just trying to think of what I have tomorrow.
hmm
Well, I guess I could do it. How long do you think it's gonna take? Like same as last time?
No, sorry, no more than an hour.
Probably in between 5 and 6 or something.
Like, is that the only gap you have in your day?
Mm. If I wake up early, I could take it.
No, like I mean, I'm watching out for you because like you have like a life busier than adults. So this is why I'm asking. So like basically like I don't want you to have to like cram it in there. Like since you have a long day, I want you to take it at 7, finish at 8. Let's like meet at 8. I don't imagine our meeting needing to be more than an hour. So we'll just meet at 8 and go. Like we should be able to finish before 9. So I'll send you the test definitely like before 5, but only take it at 7. Okay.
Okay.
Okay. All right. Have a wonderful night, and I will talk to you tomorrow. But yeah, real quick, hold on.